So let's look at partial derivative. We're looking at partial derivative of a function. So given a function f of x, which is defined in the domain D of xy plane, and we decide to keep the variable y constant in the function, then the function depends on the variable x and it has a derivative with respect to x. So if we keep y constant in the variable, meaning we differentiate the function with respect to x. And when we keep the variable x constant as well, and keep the variable x constant, then the function depends on the variable y and has a derivative with respect to y. It has a derivative with respect to y. So when y is kept constant, it means you have to find the derivative of the function with respect to the dependent variable, which is x. So as I said earlier, keeping y constant means the function now depends on x. So therefore, we are supposed to find the variable x in the function. Same applies when you keep the x constant. So for instance, if we have f of x y is equal to 2x squared y plus y cubed x, and we're asked to find f of x. If you have this function, you're asked to find f of x. Let's look at how we keep the y constant and we differentiate the x in the function. So we have to find the derivative of the function in terms of x and keep y constant throughout. So from the question that we saw earlier, we are finding f of x, meaning we find the function in terms of x, then we keep the y constant throughout the function. So f of x is equal to the f over the x. So differentiating the function f with respect to x, which is equal to f of x. So f of x means just a single derivative of the function with respect to x. Just a single derivative of a function with respect to x. So we can have higher order derivatives, that is second order, third order, and so on. So f of x is to find the derivative of the function with respect to x for just one order, for just the first order. So now let's look at how we will solve the problem with respect to x. So f of x is equal to 2x squared y plus 4y cubed x. So this is the question. F of x is equal to 2x squared y plus y cubed x. And we are finding f of x. We are finding f of x. So we keep the y constant and we differentiate the x terms. So we have x squared. We have x squared in the first term. So this is our x squared. So differentiating x squared, we're having 4x since we already have 2 multiplying the term. We're having 4x. And differentiating x, it will leave us with 1. So therefore, we're having y cubed at the other end of the function. So now f of x will leave us with 4xy plus y cubed. 4xy plus y cubed. Now, there can be scenarios where higher order derivatives can be determined from the function, such as f of xx, f of yx, f of xy, f of yyx, and etc. So we will look at how these higher order derivatives are determined from the function. So if f of x has a partial derivative of each point of the domain, then these derivatives are themselves function of x and y, and may have partial derivatives which are partial derivatives of the second, third, and fourth orders. So higher order derivatives already have their first order derivatives being determined, having their first derivatives being determined. And we have to find their second, third, or fourth order derivatives of the functions. So such higher order derivatives are f of xx, as we did earlier, which is the second order derivative of the x variable. And we have f of yy, which is the second order derivative of the y variable, and it goes on and goes on, which is f of x, xy, f of yyx, and other variables as well. So now let's look at a worked example of partial derivative, and it is given f of xy to be equal to x cubed y minus e to the power xy. Find f of x, f of y, f of yx, and f of xyy. So let's look at how this problem is solved for each derivative. So into the solution, we first find the f of x of the function. So the function is x cubed y minus e to the power xy. So we are keeping the y constant, then we differentiate the x. We are keeping the y constant, then we differentiate the x. So x cubed will leave us with 3x squared. We keep the y constant, leaving us with 3x squared y. So 3x squared y. Then e to the power xy will be, we bring the exponent down, then we differentiate the x term of the exponent that we brought down. So differentiating x, we're having 1, then we leave the y constant, then we're having y e to the power xy, y e to the power xy. So this gives the f of x of the function. Now f of y, we differentiate y, we keep x constant. So x cubed y will leave us with x cubed, because the differential of y is 1. Then e to the power xy, we bring the exponent down, then we differentiate the y term. So differential of y is 1. Then we keep the x constant, leaving us with x e to the power xy. So the next term is, we differentiate f of y with respect to x. We've already done that for f of y. So we take this function, then we differentiate with respect to x. We differentiate with respect to x. So we're having 3x squared minus y squared e to the power x, e to the power xy. So this is how partial derivatives are determined. So the last question, which is f of x, y, I'll leave it for you to solve and get to the understanding of partial derivative.